Welcome to Intelligence Gateway.
Network Architectures and Network Diagrams Lecture 18.3. Explain the concept of network architecture. The term network architecture refers to the design and structure of a computer network. It encompasses the arrangement of various components and their interconnections that enable communication and data exchange between devices within them. Network architecture lays the foundation for how data is transmitted, routed, and processed across the network, ensuring efficient and reliable communication. A well-designed network architecture considers factors such as the type of network, local area network, LAN, wide area network, WAN, etc., the hardware devices, routers, switches, hubs, etc., used to facilitate data flow, the protocols and communication standards employ, and the overall topology of the network: star, bus, ring, mesh, etc. Explain the distinctive characteristics of the mentioned network architectures and create a diagram to visually represent their structures. Peer-to-peer network architecture. In a peer-to-peer network, all devices' computers are considered equal and can act both as clients and servers. Each device can share resources such as files, printers, or processing power directly with other devices without the need for a central server. No single point of failure exists, as there is no central authority or server managing the network. Client-server network architecture. In a client-server network, there are two distinct types of devices: clients and servers. Clients are the end-user devices, e.g., computers, smartphones that request services or resources from servers. Servers are powerful computers that store data, applications, or services and respond to client requests. Thin client network architecture. In a thin client network, the majority of processing and data storage occur on the server rather than the client devices. Thin clients are minimalistic devices that rely on the server's processing power and resources to run applications and store data. The thin clients act as a user interface to interact with the applications and services hosted on the server. Research and elaborate on the possible security challenges associated with each network architecture and analyze effective strategies to mitigate these risks. Distinction, security implications, and mitigation strategies for each network architecture. 1. Peer-to-peer network architecture. Security implications: lack of centralized control. Since there is no central authority in a peer-to-peer network, it becomes challenging to enforce security policies uniformly across all devices. Increased vulnerability. Any compromised peer could potentially spread malware or gain unauthorized access to other devices. Limited authentication. Peer-to-peer networks may have weak or non-existent authentication mechanisms, leading to potential unauthorized access. Mitigation strategies. Implement strong user authentication. Require strong passwords, even multi-factor authentication to enhance user access control. Use encryption. Encrypt data transmissions between peers to prevent unauthorized interception. Maintain updated security software. Encourage users to use reputable antivirus and anti-malware software to protect against threats. 2. Client-server network architecture. Security implications. Centralized target. The server becomes a central point of attack, and successful compromise could lead to unauthorized access to sensitive data or services. Communication vulnerabilities. The communication between clients and servers may be intercepted or manipulated if encryption is not implemented. Insider threats. Malicious actors with access to the server may misuse their privileges for unauthorized actions. Mitigation strategies. Harden the server, regularly update and patch server software to address known vulnerabilities. Encrypt communication. Use secure communication protocols, e.g., TLS, SSL to protect data in transit. Implement access controls. Enforce strong access controls to limit user permissions and prevent unauthorized access to sensitive data. Regular audits and monitoring. monitor server logs and conduct security audits to detect and respond to suspicious activities promptly, implement intrusion detection, prevention, systems IDS, IPS. These systems can help identify and block suspicious network activity. 1. Virtualization. Virtualization is a technology that allows multiple virtual instances of operating systems, applications, or hardware resources to run on a single physical machine. It abstracts the underlying hardware, enabling better source utilization and flexibility. Key characteristics: resource consolidation. Virtualization allows multiple virtual machines VMs to run on a single physical server, reducing hardware costs and improving efficiency. Isolation. Each VM operates independently of others, providing strong isolation and security for applications and data. Mobility. VMs can be easily moved or replicated between different physical servers, facilitating workload migration and disaster recovery. 2. Cloud computing. Cloud computing is a model that delivers computing resources such as servers, storage, databases, networking, and software over the internet. It offers several distinct features. On-demand self-service. Users can provision resources automatically without human intervention from service provider. Elasticity and scalability. Cloud services can scale resources up or down based on demand, ensuring efficient resource allocation. Pay-as-you-go model. Users are billed based on their actual usage of resources, providing cost-effectiveness and flexibility. 3. Bring your own device BYOD. BYOD is a policy that allows employees to use their personal devices such as smartphones, laptops, and tablets for work-related tasks. Key characteristics include increased flexibility. Employees can use familiar devices, boosting productivity and job satisfaction. Cost savings. Organizations can save on hardware expenses since employees use their own devices. Security challenges. BYOD introduces security risks, as personal devices may not have the same level of security as corporate-owned devices. Mobile device management (MDM). MDM solutions are employed to enforce security policies, protect corporate data, and remotely manage devices. 4. Software-defined networking (SDN). SDN separates the control plane from the data plane, centralizing network management and allowing more dynamic and programmable network configurations. Key characteristics include centralized control. SDN controllers manage the network, making it easier to implement changes and policies across the network. Network automation. SDN enables automated network provisioning and configuration, reducing manual intervention. Flexibility and adaptability. Network resources can be easily reconfigured and scaled as needed to meet changing demands. Open standards. SDN relies on open protocols and APIs, fostering interoperability and encouraging innovation. 5. Storage-defined networks. Storage-defined networks (SDNs) are a storage virtualization technology that separates storage resources from the physical infrastructure. Key characteristics include storage pooling. SDN aggregates physical storage resources into a single virtual storage pool, simplifying management and utilization. Dynamic provisioning. Storage resources can be allocated and scaled on demand, improving resource efficiency. Data tiering. SDN allows data to be categorized based on usage patterns, enabling optimized storage allocation. Improved data protection. SDN allows data to be categorized based on usage patterns, enabling optimized storage allocation. Improved data protection. SDN enables data replication, snapshots, and backup for enhanced data protection. Investigate and elaborate on the possible security challenges associated with each. Contemporary allows data to be categorized based on usage patterns, enabling optimized storage allocation. Trend and analyze effective strategies to mitigate these risks. Distinction. 1. Virtualization. Security challenges. Hypervisor vulnerabilities. The hypervisor, responsible for managing virtual machines, can be targeted by attackers to gain control over multiple VMs. VM escape. An attacker gaining unauthorized access to a VM may attempt to escape and access the underlying host or other VMs. Data leakage. If VMs are not properly isolated, sensitive data from one VM could be accessed by others. Insecure VM images. Using pre-built VM images without proper security hardening can lead to vulnerabilities. Mitigation strategies. Hypervisor security. Regularly update and patch the hypervisor software to address known vulnerabilities. Isolation and segmentation. Implement strong isolation between VMs to prevent unauthorized access. And data leakage. VM hardening. Apply security best practices and harden VM images before deployment. VM monitoring. Use monitoring tools to detect abnormal behavior and potential VM escape attempts. Access control. Restrict access to critical hypervisor components to authorized personnel only. 2. Cloud computing. Security challenges. Data breaches. Cloud services store vast amounts of data, making them attractive targets for cyber attacks. Shared resources. Shared infrastructure can lead to security risks if other tenants' activities impact the security of your data. Compliance and regulatory concerns. Cloud providers' locations and data handling practices may not comply with all jurisdictions. Lack of control. Cloud customers may have limited control over security configurations and mechanisms. Mitigation strategies. Data encryption. Encrypt sensitive data before storing it in the cloud to protect against unauthorized access. Security assessments. Perform regular security assessments and audits to ensure the cloud provider's compliance and security practices. Cloud security solutions. Utilize cloud-specific security tools and services like Cloud Access Security Brokers (CASBS) and cloud firewalls. Service level agreements (SLA) letters. Negotiate SLA letters with the cloud provider to establish security responsibility and accountability. 3. Bring your own device BYOD. Security challenges. Lost or stolen devices. BYOD increases the risk of lost or stolen devices containing sensitive corporate data. Malware and phishing. Personal devices may not have adequate security measures, making them vulnerable to malware and phishing. Data leakage. Mixing personal and corporate data on the same device could lead to data leakage. Device compatibility. Ensuring security across various device types and platforms can be challenging. Mitigation strategies. Mobile device management (MDM). Implement 10DM solutions to enforce security policies, remote WiPE capabilities, and data encryption. Containerization. Use containerization to separate personal and corporate data on BYOD devices. BYOD policy. Establish a comprehensive BYOD policy that outlines security requirements, acceptable use, and user responsibilities. Employee education. Conduct regular security awareness training to educate employees about potential risks and best security practices. 4. Software-defined networking (SDN). Security challenges. Centralized control. An attacker gaining access to the SDN controller could manipulate network traffic and cause disruptions. Insecure APIs. Insecure or improperly configured APIs could be exploited to compromise network security. Overlapping network zones. Improperly configured SDN can lead to overlapping network zones on unauthorized. Mitigation strategies. Access control. Implement strict access controls and authentication mechanisms for the SDN controller. Secure APIs. Ensure APIs are secured with strong authentication and encryption. Network segmentation. Properly segment the SDN network to prevent unauthorized access and traffic interference. Network monitoring. Deploy network monitoring tools to detect unusual network behavior and potential attacks. 5. Storage-defined networks. Security challenges. Data exposure. Improper access controls or misconfiguration could lead to unauthorized access to sensitive data. Data integrity. Ensuring the integrity of data stored in the virtualized storage environment is CROC. IAL. Data redundancy. Replicated data increases the risk of exposing sensitive information. Mitigation strategies, access control, implement granular access controls, and authentication to restrict access to storage resources. Data encryption, encrypt data stored in storage-defined networks to protect it from unauthorized access. Auditing and monitoring, regularly audit storage activities and monitor for any abnormal behavior or access attempts. Data backups, implement robust data backup strategies to ensure data integrity and quick recovery in case of data loss or corruption. Progress check.
Thanks for watching. For more information, like, comment, and subscribe our channel.